Okay, so the idea here with number 25 on section 6.4 is that we have this kind of inverted cone shaped tank, and it doesn't go all the way down though. And that's actually the source of the main difficulty with setting up this problem, is that it's cut off at the bottom. So we're going to sort of proceed as normal, right? And we're going to slice it, say, right here. And obviously, at some point in your work, you will need to determine this value of r, which is going to depend, of course, on where we're making the slice, right? So closer to the top, we'll have a large r value. Closer to the bottom, we'll have a small r value. Okay, very good. So what we need to do is impose a coordinate system, of course, and we can just sort of define this length there as x, although perfectly well you could make x the length above it instead. All right, so what we need is r in terms of x, because everything will be in terms of x for the setup of our integral. Now, for many of these types of problems, we can determine r in terms of x by setting up similar triangles and then taking advantage of the proportion that emerges. But of course, as noted in this problem, that's not so straightforward because we don't have any kind of obvious triangles. So the trick to getting this is let's look at this thing kind of orthogonally. So meaning not as like a 3D object, but sort of as a 2D object. So there's like our cross section, and we know that our r value is right here, and of course we have our x value like that. Now it's given in the problem that this is a 6 feet across the top. I'm just going to omit the units for clarity. And we have 3 feet at the bottom here. So what we're going to do is kind of complete the rectangle here. And that extends this a little bit out as well. There we go. So we kind of have a rectangle, and we know that this little length right here has to be 3 because, 3 plus 3 is 6. It has to match what's at the top, which is a 6. Okay, and we're also given that the height of this tank is 8 feet, which means this entire length here is 8. Now what we're going to do is take advantage of the similar triangles that we have here. So we have this triangle right here. Let's just kind of lift it out. And we can see that its base is all of this length, which is 6 minus r. And we can see that its height is 8 minus x. Okay, and then we also have the kind of outer triangle, which is similar to it, which has a base of 3 and a height of 8. So now we do have a similar triangle situation, and we can use this to determine r in terms of x. So of course we will just say, well, 6 minus r is to 3, as 8 minus x is to 8. And there you are, you have a way of solving for r. Now this isn't actually the only way you can do it. You can also just simply impose an actual literal coordinate system, with the x and y axes, and determine the equation of this diagonal line here according to its slope of 8/3. And then, you can determine what r is using just the coordinate system. But this is a perfectly reasonable way to do it right here, and this will get us the right answer. So I hope this helped.